ओके तो बेटा दिख रहा है ये आपको क्वेश्चन? हेलो। ओके so today we will start the previous year questions of chemical kinetics. नेक्स्ट के प्रीवियस ईयर क्वेश्चंस करते हैं. ओके बेटा सुनाई दे रहा है ना? ओके तो 2025 में ये नेक्स्ट में क्वेश्चन आया हुआ है. कंसीडर टू रेडियोएक्टिव सब्सटेंसेस P and Q that decay following a first order kinetics. If even if it is not written that it follows first order kinetics, whenever radioactive decay takes place or nuclear reaction, any nuclear reaction takes place that follow first order kinetics. Keep in mind it takes 9 years for P for decay of 2/3 of its initial amount. In the same 9 years Q decays by half. So if ratio of the initial amounts of P and Q are given to you, that is 81:16, number of years after which the quantities of P and Q would be same, that we have to calculate. तो सबसे पहले हमारे पास जो रेशियो दी है, this is the initial ratio of P naught to Q naught, that is 81:60. अब जो P है that takes 9 years for decay of 2/3 of its initial amount. That means 2/3 तो decay हो गया, तो बचा कितना? 1/3. So you know that P is equal to P naught e raised to power minus kt, or in this case you can write lambda, but anyhow write it k. Same Q is equal to Q naught e raised to power, now this is kp and this is kq, because P and Q, there are two different radioactive substances, so their decay constants are different. So this is the ratio. P is equal to P naught e raised to power minus kt, and Q is equal to Q naught e raised to power minus kt, but K are different for P and Q. So ये दो रिलेशन जो है आपने पहले लिख दिए. Now after 9 years, P decay means decay by 2/3 of its initial amount. So after 9 years, P is equal to P naught by 3, and Q, that is equal to Q naught by 2, because in the same 9 year Q decays by half. That means for Q 9 years is its half life, right? Now if we write the ratio, P upon Q is equal to P naught upon Q naught into e raised to power minus kpt upon minus kqt. That means it becomes kq minus kp into t. This is the relation. Now let us calculate kp. So what is k? 1 upon t natural log of p naught upon p, that is kp. And what is kq? 1 upon t natural log of q naught upon q. In this case, you know, for q, 9 year is half life. So what is the relation between kq and half life? Kq is equal to natural log of 2 upon 9. You know, for first order kinetics, relations are any r, any constant after time t is equal to r naught e raised to power minus kt, or t is equal to 1 upon t natural log of, sorry, k equal to 1 upon t natural log of r naught by rt, or t half is equal to natural log of 2 upon k, or we can say 0.693 upon k, or it can be written as natural log of 2 upon k. So in this way, kq becomes natural log of 2 upon 9, and what is kp? 1 upon 9 into natural log of p naught divided by p naught by 3. That means it becomes natural log of 3 upon 9. So kq equal to natural log of 2 upon 9 and kp equal to natural log of 3 upon 9. Okay. So now this relation p upon q equal to p naught upon q naught and e raised to power kq minus kp into t. So what is p upon q? See, we have to calculate number of years after which quantities of p and q would be same. So let us say after time t, p becomes equal to q. That implies p upon q is equal to 1. So 1 is equal to, what is p naught upon q naught? 1881 by 16, and e raised to power kq, that is natural log of 2 upon 9 minus natural log of 3 upon 9 into t. So it becomes 16 by 81 is equal to e raised to power natural log of 2 minus natural log of 3 into t by 9. ये वैल्यू आ गई. So if we use natural log of 16 by 81, it becomes natural log of 2 minus natural log of 3 into t by 9. You know, natural log and this exponential, natural log of exponential is 1. So this whole thing becomes natural 2 minus natural 3 into t by 9. So what is natural log of 16 by 81? It is natural log of 2 by 3 raised to power 4. That is equal to natural log of 2 by 3 into t by 9. So it becomes 4 into natural log of 2 by 3, that is equal to natural log of 2 by 3 into t by 9. So cancelled. So 4 is equal to t by 9. So t is equal to 4 into 9. That means t is 36 years. Got it? That means 36 is the right answer. Yes, beta.
Sir,
Yes, beta.
sir, after time t, variability t is equal to t.
After
Sir, you said that we are doing at time t, p is equal to q.
yes, because we have to calculate number of years after which quantities of P and Q would be same. Read the last statement. We have to calculate number of years after which quantities of P and Q would be same. That means after time t years, because t we have to calculate. So after time t years, P would be equal to Q, and that time we have to calculate. Got it? So P is equal to Q. Let us say if P becomes equal to Q after time t years. So that t years we have to calculate. So we have, you can write it like this as well, that P is equal to Q after time t. So it is P naught e raised to power kpt Q naught e raised to power minus kqt. You can go like this as well. Hmm? Means our aim is to calculate time t, after which quantities of P and Q would be same. Okay. Next question. Consider the first order reaction X gas to give 2Y gas studied as a function of time at constant temperature and volume. Now at any instant of time, total pressure of the system is denoted by capital P, while Y is the concentration of species Y. And what is Y? Y is the product. Assuming ideal gas behavior of the reaction mixture, starting with 1 mole of pure X. there is 1 mole of pure X. So what is correct plot? So initially we have 1 mole of X. At time t, let us say it become 1 minus X. So it is 2X. So total moles after time t, that is 1 plus X. That means initially it is 1 mole and after time t it become 1 plus X. Now first let us discuss these two plots. You know PV equal to nRT. That implies PV upon RT is equal to N. So initially at time t0, PV upon RT equal to 1, and after time t, PV upon RT becomes 1 plus X. That means initially it is 1 and after time t it becomes 1 plus X. And at infinity it becomes 0, so it becomes 2. That means at t infinity, means after completion of the reaction, PV upon RT becomes equal to 2. So now tell me, D plot is not correct. Why? Because with the time, PV upon RT does not change. PV upon RT becomes 1. That is not true. Now come to C. PV upon RT, initially it should be 1. And as the time progresses, it increases and touches 2. Plot should be like this. It is not like this, because initially it is 2 and then becomes 1. But actually it is initially it is 1 and then it becomes 2 after infinite time. Okay, so C plot is also not correct. Now come to rate versus Y. Actually it is first order reaction. So first order reaction, what is rate? Rate is equal to K into concentration of X. That is reacted. But we have to write it in terms of concentration of a Y. So what is concentration of Y? Y is equal to 2X. That implies X is equal to Y by 2. And this rate becomes, it is 1 minus X. After time t, it is 1 minus X. That is K minus Kx. But in terms of Y, it becomes K Y upon 2. That means if we plot a graph, rate versus Y, कैसा ग्राफ आएगा? Yes बेटा, rate is Y is equal to C minus mx. Straight line equation हुई with negative slope. So it is like this. Intercept is K. and slope is minus k by 2. That means B option is correct. Yes, but I got it.
Can be A also.
But if it is x, even then, you know, rate versus y, it is a straight line graph. See, because rate is power 1, y is power 1, because it follows first order kinetics. That's why it is like this. It is a straight line graph. It is not exponential, because it is rate versus y. Same if it is rate versus x, then it is like this. It is a straight line graph because power is 1. Okay, here it is exponential. We see curved graph. It is not straight. It should be straight line. Okay, consider the first order reaction, X gas to 2Y gas plus 2Z gas involving ideal gases X, Y and Z inside a reaction chamber of fixed volume and at constant temperature. Initial at time 0, pressure is 1 atmosphere, and after 30 minutes, total pressure increases to 2.5 atmosphere. So what is the fraction of unreacted X at time t equal to 1 hour? So see, we have this reaction, X gas to give 2Y gas plus 2Z gas. There are ideal gases X, Y and Z inside the reaction chamber of fixed volume and constant temperature. Initially at time t0, pressure is 1 atmosphere, and after 30 minutes, one minus P, it is 2P. Now, what is total pressure? 1 minus P plus 2P plus 2P, that is equal to 2.5. So 1 plus 3P equal to 2.5. That implies 3P equal to 2.5 minus 1, 1.5. So P is equal to 0.5. So in 30 minutes, what happened? X changes from 1 to 0.5. That means it is half-life. Half-life is 30 minutes. I hope you got it. Pressure of the X in 30 minutes changes from 1 to 0.5. That means it becomes half, and it follows first order kinetics. So half-life is 30 minutes. So what is the fraction of unreacted X? That is 1 upon 2 raised to power n, because you know amount left after n half-lives is a naught by 2 raised to power n. This is the fraction of a after n half-lives. Now 1 hour, how many half-lives? And if we talk about fraction of a, that is an upon a naught, that is 1 upon 2 raised to power n. Okay. So what is fraction? In 1 hour, how many half-lives are there? Hmm? 2. Very good. Because one in half-life is 30 minutes. So in 1 hour there are 2 half-lives. So it is 2 raised to power 2. That is 1 by 4. So in percentage, it is 1 by 4 into 100. That is 25%. So option B is correct. Okay. Okay. Consider the radioactive decay X radioactive to Y stable. At time t0, X is present in the pure form, and at 2 hours, time 2 hours, ratio of the amounts of X and Y is 1:3. So what is the duration required for the ratio to become 1:15? That we have to calculate. So see, we have X to Y. So ratio of amounts of X and Y after 2 hours. So what is initially, whatever amount of X is present, ratio is 1:3. So what is fraction of X after time 2 hours? Fraction of X is equal to, what is the fraction of X? Yes, beta. What is fraction of X on a reacted? Because amount of X is 1, and what is the total amount? 4. So 1:4. That means 1 upon 2 raised to power 2. तो यहां से अगर आप इसको रिलेट करो, fraction of unreacted is 1 upon 2 raised to power n. So that means 2 hours are 2 half-lives. That means what is half-life? Half-life is 1 hour. So now duration required for 1:15. That means fraction of unreacted X equal to 1/16. That is 1 upon 2 raised to power 4. ठीक है? 1 upon 2 raised to power 4 means 4 half-lives. 4 half-life means 4 hours. So duration required for the ratio to become 1:15 is 4 hours. कैसे किया मैंने, सिर्फ पिछले क्वेश्चन को रेफरेंस लेके आप यू कैन डू इट. Ratio of x is to y is 1:3, so amount of x unreacted is 1:4, and duration required for the ratio to become 1:15, so it is 1:16. Yes beta. Yes, actually देखो, say this one, amount of reactant, let's say A, left unreacted after n half-lives, that is equal to, let us say An. This is the fraction of reactant left unreacted after n half-lives. Now, fraction of A unreacted, that is An upon A naught, that is 1 upon 2 raised to power n. Okay, got it? So now here see, ratio of x and y, that is 1:3. So what is fraction? That is the amount of x divided by total, that is 1/4. So in terms of 2, it is 1 upon 2 raised to power 2. So that means it needs 2 half-lives for getting this fraction. So now time required for this is 2 hours. So that means 2 hours are 2 half-lives. Means 2 half-lives equal to 2 hours. So 1 half-life is equal to 1 hour. That's it. See, what is fraction? Fraction means amount of that component divided by total. So x is 1, y is 3. So what is total amount? Same is the case here. 1 is to 15. X is 1, y is 15. So total is 16. And x is only 1. So 1 is to 16. So that means 1 upon 2 raised to power 4. It is 4 half-lives. 4 half-lives is 4 hours. Okay? Okay. Temperature dependence of the rate constant of a chemical reaction can be expressed in terms of Arrhenius equation, which contains the corresponding activation energy term. The correct plot of the ratio of the rate constants of different chemical reactions at 2 temperatures as a function of their activation energy. It is, I think it is kilojoule per mole. Okay. So now Arrhenius equation, I think you know this what is Arrhenius equation? It is natural log of K2 by K1 equal to EA upon R 1 upon T1 minus 1 upon T2. This is extended form of Arrhenius equation because already natural log of K400 to K300 it is given. So that means it becomes natural log of K400 to K300, that is equal to EA divided by R 1 upon 300 minus 1 upon 400. So it becomes EA by R 300 into 400 and 400 minus 300, that is EA upon R into 100 divided by 300 into 400. Means 2 0 cancel. It becomes EA upon 1200 into R. Now natural log of K400 to K300 equal to EA upon natural log of 2, that you have to write natural log of 2 or natural log of 4, but in 3 cases it is natural log of 2, so let it be natural log of 2 first. So if we write natural log of 2, we have to multiply it by natural log of 2, and what is left? 1200 into R. Okay, so this is Y, this is X, and this is M, that is slope. So M is equal to natural log of 2 divided by 1200 into R. So natural log of 2, you know, it is 0.693 divided by 1200 into 8.3 into 10 raised per minus 3. 8.314 into 10 raised per minus 3. Actually, R is equal to 8.314 joule per Kelvin per mole, or it is equal to 8.314 into 10 raised per minus 3 kilojoule per Kelvin per mole. So we will write it like this. So it is 0.693 into 1000 divided by 1200 into 8.314, again 20 cancelled, so it becomes 0.693 into 10 divided by 12 into 8.314. So it is almost 100 because 12 minutes are 96. It becomes 0.0 So slope should be 0.0693, and it is a straight line graph. Reason being, natural log of k 400 upon k 300, it is y, that is power 1. EA upon natural of 2, it is again power 1. So it is a straight line graph passing through region. All the graphs are passing through region except C and D. So C and D are not correct options. So they are cancelled. We left with these two. Now what is slope here in this case? Slope is equal to 1.38 minus 0.69 divided by 20 minus 10. So it is 0.69 by 10, 0.069. So that means A is the correct option. In the other case, it is same plot but with natural log of 4. It is not with natural log of 4, it is with natural log of 2. Slope is 0.069. So option A is correct. Yes, beta. Did you understand this part? Because it starts from somewhere else. It is not starting from origin. Because C is 0. In this case, C should be 0.69. Here C should be 0.23. But you know, in our equation, C is 0. There is no C. There is no intercept. There is only slope. So it is y equal to mx only. Equation is y equal to mx only. There is no C. Okay. Got it, beta? Next question is hydrolysis of sucrose in excess acid solution. It follows first order kinetics and results in D-glucose and D-fructose. Since sucrose, D-glucose, D-fructose all are optically active compounds, progress of the reaction can be monitored by measuring the angle of rotation of the polarized light in a polarimeter at different times. Actually, polarimeter is an instrument which is used to calculate the angle of rotation. Actually, sucrose, when it is hydrolyzed, we get glucose and fructose. So glucose is dextrorotatory. Glucose, sucrose, glucose both are dextro, but fructose is levo. And levo rotation of fructose is more than dextro rotation of glucose. So overall this mixture is levo rotatory. So when hydrolysis of sucrose takes place, dextro rotation decreases. Dextro means plus and levo means minus. So initially when sucrose is present, its rotation is plus 25 degree. After 30 minutes, that becomes 5 degree. And at infinity, because at infinity all the sucrose is hydrolyzed, so value becomes minus 15 degree. Levo rotation. This is also called inversion of sucrose. Inversion of sugar or inversion of sucrose और glucose fructose का जो mixture है, that is called invert sugar. because in sucrose there is 1 unit of glucose and 1 unit of fructose. Okay, and after time, after completion of the reaction, the glucose or fructose we will get, the overall rotation becomes levo, dextro to levo. That's why it is called inversion of sucrose, inversion of sugar, or simply hydrolysis of sucrose. Now, this is the reading. Initially it is 25 degree. After time 30, it becomes 5 degree. And after completion of the reaction, it becomes minus 15 degree. This is the order. Now, according to the statement, concentration of the sucrose at time t, that is proportional to change in the angle of rotation, that is RT minus R infinity. This is a change in the concentration of sucrose at time t, that is proportional to change in angle of rotation. That means what is the concentration of sucrose initially? That is R naught minus R infinity. That is initial concentration of sucrose. The initial concentration of sucrose is R naught minus R infinity, and concentration of sucrose at time t, that is RT minus R infinity. So equation T is equal to 1 upon K natural log of R naught is initial concentration. So it is R naught minus R infinity, and after time t, it is RT minus R infinity. This is the relation. So what are the correct statements? First, calculate the rate constant. So let us calculate the rate constant. The rate constant K is equal to 2.303 by T log of R naught minus R infinity divided by RT minus R infinity. So K is equal to, after 30 minutes, it is 30, because half-life is given in minutes, but rate constant is given in per second. Rate of reaction is also given in mole per liter per second. So time we have to convert into seconds. 30 into 60 log of, what is R naught? R naught is 25 minus R infinity, that is minus 15, divided by 5 minus 50. So it is 2.303 by 30 into 60 log of 40 upon 20. Log of 2, that is 0.693 by 1800. So what is the value? So rate constant in terms of 10 raised power minus 4. So it becomes 69.3 by 18. So what it, 18 3s are 54. 54 means 15 left, 153. It is 3 point. So it should be very close to this value. That means this is true. This statement is true. And what is half-life? Tell me. What is half-life? One. What is half-life? Yes, beta. See, this is again 0.693 upon 1800. So for first order kinetics, it is 0.693 upon T half. And what is T half then? This is only T half, that is 30 minutes or 1800 seconds. That means A option is incorrect. So what is the amount of X after 60 minutes? Sixty minutes becomes how many half-lives? 2. So it is A naught by 2 raised to power n. A naught 2 raised to power 2. So what is the initial amount divided by 4? That is the amount left after 60 minutes. So what is initial amount? 1 liter 0.1 molar. How many moles? Initial moles of sucrose. That is A naught. That is molarity into volume in liter 0.1. So amount of sucrose it is 342.3. So it becomes 34.23 gram. That is the initial amount. So amount of sucrose after 60 minutes, that is equal to 34.23 divided by 4. In a certain experimental 1 liter of 0.1 sucrose is hydrolyzed and then angle of rotation. So we have to calculate mass of sucrose hydrolyzed in 60 minutes. This is the amount of sucrose left after 60 minutes. So hydrolyzed means 1 minus that amount. So amount left after 60 minutes is 8 for the 32, 5 for the 20, so 23, almost 8.5. 5. So amount of sucrose hydrolyzed, that is equal to, initial it is 34.23 minus 8.55. So how much left? 34.23 minus 8 point, it is 25.68 gram almost. So C option is also correct. Now rate of reaction at 30 minutes. The rate of reaction is K into concentration of sucrose at 30 minutes. Tell me, after 30 minutes how much sucrose is left? It was sucrose to give glucose and fructose. So initially we are having 0.1 molar sucrose. 30 मिनट्स के बाद कितना हो जाएगा? 30 minute is half life. So 0.1 becomes 0.05. So K is 3.85 into 10 raised by minus 4 and it is 0.05. कितना हो जाएगा? 3.85 into 0.5 into 10 raised per minus 5. So half of this is 1.925. That means rate of reaction at 30 minutes is also, that means B, C and D options are correct. Got it? Actually, polarimeter will give us the change in angle of rotation, and angle of rotation, that change tells us how much sucrose is hydrolyzed, because dextro rotation decreases and levo rotation increases, because the levo rotation of fructose is more than that of glucose. ओके, तो बाकी क्वेश्चन हम 5:30 पे शाम को फ्री हैं आप लोग? क्लासेस है? Okay, so tomorrow at 8:30 I will take class. Okay.